This time on the Random Junk channel, we're going to be repairing a Department 56 Gondola Circuit Board. So if you have the gondola, it's got the tall mountain on one side and the short mountain on the other with the two cars. I think they're like red and yellow. Yeah, red and yellow since it's behind me. They go back and forth and stop and reverse and stop and reverse. And if you ever open one, they're full of rocks, and you'll learn the hard way when they spill everywhere. But anyway, underneath the small house is the control board. They're really commonly, or they're most commonly known for failing. So it goes in one direction, it fails, and then it burns out the entire board. So here's the board. I already removed it from the gondola before doing this because this is going to be a very long video, probably very boring for most of the folks that you're watching this. But if you have this piece and you want to rebuild the circuit board, it might be helpful. So anyhow, I got the board from Happy Holiday Parts, the rebuild kit. Here's the rebuild kit. A lot of little baggies with a lot of little parts. So, comes with a tip of the day. Make sure you use the right adapter or else you're going to fry your transistors. That's what Q means on electronics code, means transistor. And then page 2 is to make sure you got all the parts, which are all in these baggies right here. And then it shows your circuit board right there. We'll even turn it so it matches the picture. There you go. Hey, look at that. So, there's that. So here's our transistors, resistors, and more transistors because there's two different types. Your IC chip and IC chip holder. That's this. That's actually what fries. And then it does fry these 4 transistors right here. We got the more resistors, capacitors, and more transistors. So yeah, you got, and a Zener diode in there. So you got all sorts of little pieces. So this video is going to be very long, and so I just want to preface, if you don't want to watch it, I understand. But if you have this piece and it fails, hopefully this will help you. I'm going to try and zoom in somewhat to the process to make it a little easier. So I have the soldering iron on, heated up already, saves time. I'm going to use a solder sucker, flux, solder, helping hands, circuit board, and all the little pieces. Normally it's the switch that fails, but on this one it's the chip. I had it working, and if I squeeze the chip, it goes back and forth. If I let go of the chip, it fails. So it's a bad chip, but when you replace the chip, you need to replace everything else, so all the resistances are good. Are all the loads. And this is the power switch. Since I'm not desoldering it from the board, here's the incoming power port. And this goes to the motor, and the board actually says M plus and M minus right there, which means motor. So, first things first, I'm going to get this clamp into this as best as I can. Don't need the magnifying glass because I'm wearing them on my head. The easiest way to do this is to remove one component at a time and then replace them as you go. Actually, I'm just going to flip the board. So the components are on the back side, but they're soldered through, or sorry, the top side, and they're soldered through to the bottom side. What I'm going to do is I'm going to start fluxing everything so I can start desoldering it. I'll probably desolder most of these joints all at the same time. That way I only have to worry about getting the components out. And like I said, I will zoom in. I'm not going to remove the big switch. Like I said, I tested that and it actually works. I do have a spare somewhere. I think I got them all. So what this is going to do is it's going to allow better heat transfer of the soldering iron to pull out the solder. So solder sucker, this one uses your thumb, and then when you put it next to the solder, it sucks it up, so you get rid of these nice shiny silver domes. You can use solder wick. I don't use it. I have some. I don't like it. When I learned how to solder, we use these, and I've never gotten the solder wick down. But if you have solder wick, or you don't know what solder wick is, it comes in a roll like this, and then you pull it out, and then you solder. You heat this up with flux, and the solder transfers to this and removes it from the board. So I do have rolls of it because it does come in solder kits. I do use it occasionally, but I prefer the solder suckers. And they actually have them that are vacuum versus old school, which for something like this would be way easier. So let's zoom in a little. It's going to be far from me for doing this, but hey. So that's about as close as I'm going to get. Not because I'm trying to hide something, because the center, it zooms into the center of my bench, and that puts it too far from my working area. So, all right, well, now we're going to start. This is for cleaning the tip of the soldering iron. It's just a copper mesh, kind of like one of those scrubbies you use for scrubbing pots and pans. I'll be needing it a lot to, instead of reaching over and doing it, I'll put it next to my work. All right, so we'll start here. That's a capacitor that's about to fall out. Come on. So if I wasn't filming this, because I've shown it before, I'd be doing this while listening to music or a podcast or something. So if you're doing this at home, you can pop something on, because this is going to be tedious. Just make sure whatever you're doing doesn't distract you when you do the reassembly, because you do not want to screw up where the components go. But that's any circuit board. It doesn't matter if it's the gondola or a television. So every time I push it back down, if you've never seen one of these before, it pushes the solder out, so there's flakes of solder everywhere. I'll vacuum it up when I'm done. If I had a vacuum solder sucker, where it's just connected to a little vacuum, it would hold it in a little tank. But like I said, I'm not that fancy. So you can see the divots that is formed and the peaks, and that's all this does. And it's a heck of a workout for your arm and thumb, I'm going to tell you that. Now some of these big ones you'll have to suck it multiple times because it's just too much material. Or that's where the vacuum one comes in handy, because the vacuum one will, you just hold it there till it's all gone. Probably helps if I This is 3 pads all connected together, so there's a lot of solder on that one. I unsoldered the switch. I didn't mean to. That's fine. I'll solder it back in. Alright, well, one of the components just fell out, so let me turn it over and see what it was. It's nice as I have another one of these circuit boards, just in case, to compare. So I lost the capacitor right there, which is the same as the other capacitors. Not a big deal. So, the capacitor fell out right here, and the capacitor is right here. It's one of the problems when you do this upside down, is if you get too much of the solder out, the components will literally just fall out. But back. I have the board turned around so I can actually see the ones I'm missing, which there's still several of them. Alright, I think I got them all for the most part. Might have to still touch them when I'm pulling the components out, because there might be residue inside the thickness of the board of solder that's still adhered. So, but flip this back over. So this one's also loose, which is also number 104. So these capacitors say 104 on them. And now we go through the parts and we find the little 104 capacitors. That's not it. Actually, that might be the replacements. They changed a few things C1, C2, and C3. Yep, so these are the replacement capacitors. They're physically larger. Yeah, it's D1, D2, C1, C2, C3. Replaces part number 104 capacitor. So, these capacitors are larger. These are unidirectional. Most capacitors aren't, but these little flat guys are. So, we're going to shove that through. And we're going to shove that through. You know, I should look to make sure I'm still on camera. I'm not on frame. That was my problem. So, all right. So, these little guys are replaced with these big guys. That's the problem with zooming in, is I don't know where my frame is, especially if I'm looking down. So here's the replacements for those. So on this baggie, part 104 cap. 104. These are the new replacements. They're larger. And so we're going to get those put on real quick. We're going to start with those only because 2 of them fell out. And this is how you do it so you don't lose what you're working on. Meaning that you're you don't pull all the components out and then not remember where the components go. So as you remove, you replace. And you really can't screw up these capacitors because, well, they're much, much larger. So let's take the capacitors through. So I'm going to turn them around. So when you put them in, find the best fitment for the 2 that are next to each other, because one leg is straight, one leg is bowed. I'm going to put the bowed leg so they're away from each other so they don't arc since they're larger. There we go. It's just the motor wires that fell off. I'm still in frame, right? No. I gotta remember not to cross this line. So, 1 capacitor, 2 capacitor, 3 capacitor. So now, their legs are bent on the other side now. So when I flip it over, it won't fall out. And now I can solder those in. Well, 2 of them are bent, 1 of them just slid back, no problem. I'll grab that. So to prevent overheating of the component, I do 1 leg on 1 component and then I go do another one. And then I go back and forth if this thing wants to. There we go. Now I'm going to push this guy back in since I didn't get the legs to twist. So to prevent it from falling, you can bend the leg. Well, the other 2 bent before I even did it, and this one didn't, so oh well. And you're probably thinking, oh, you didn't cut the legs. Don't worry, I'll cut them after. I will want to have the extra length to help dissipate the heat. The heat will travel down the leg and not travel into the capacitor itself. Just checking my solder joints to make sure they're good. I don't like this one. I think the soldering gun, or soldering pin, there we go, was too dry, meaning I didn't have enough solder on it to help wick the heat. Now we take our snips and we get better snips because those look like garbage. Yeah, these are garbage. So, better cutter snips or flush cutters. We cut off the 6 extra long leads, like so. And there's our new capacitors. I'm going to go ahead and resolder the positive and negative real quick, since I sucked the solder off of them, so there's nothing holding them in. So let's do those real quick. It's upside down. I didn't know what was what. There we go. So that's soldered back in. I'll solder the motor wire in later. So now we're going to try and take the chip out. So to do that, I'm going to first pry on it a little bit and see how much of the solder separated. Not enough to separate the chip yet. So this is where we're going to have fun. So a component that has 2 or 3 leads, they're really easy to pull out. When a chip has 16 leads, if there's solder on 3 or 4 of them still, it makes it really hard to remove it. Now they do have this thing called a rework station, which is actually what I'm using, that uses air to melt all the solder. The problem is it melts everything, and if you don't do it right, you'll also melt the green off the board, and that would be bad. So I'm just going to hit him again and try and do a little bit more solder sucking, but let's re-wet them with some flux. Nice little puddle on it. Like so. Now, computer chips or IC chips or the like, they can only be put in one way. You cannot put them in backwards or upside down, or else you will destroy the chip. They are super, super sensitive to electricity, which includes static electricity. So when you do the chip, make sure that you're grounded. So you can get a ground strap. And it plugs into the ground of your receptacle. I do have one. Or you can ground yourself to wrap a piece of copper wire around your wrist and do the same thing, because an electrostatic discharge will fry the chip. This chip is bad, so I don't care, and I'm trying to get it out. It doesn't want to come out because of the amount of friction with all the pins and the amount of solder. So now the new chip is nice because it's, there we go. It still has the same properties, but you don't solder the chip in, because one of the biggest failures for ICs is heat. What do you think a soldering iron is? So he actually includes a IC holder, which is what a lot of companies have gone to reduce the heat from the computer chip. So here's your IC, which is now going in the receptacle. I'm going to check out all the holes to make sure I can see through them all, because in this baggie right here, open, is one chip and 1, chip holder. So there's the chip, and there's the chip holder. Boop. Just like that. And we'll flip it over. So if you can see, you see that notch up here? Sometimes they put a dot. That means the front of the chip. So the chip has a mark that tells you which is the top of the chip or the front of the chip, or where pin 1 is basically what the concern is. If you look at this IC holder, it's kind of hard to see, it's black on black. You see there's a notch on this end, and it's flat on this end. And that's so you put it in the right direction. So it takes the image on the board and makes it three-dimensional. So now we got to put this in. So this is just an IC holder. It doesn't have a issue with electricity, meaning, or static electricity. It just transfers the chip info. I'll probably be off camera for a second while I try and get all the pins to line up, because the pins aren't perfectly in parallel, so I've got to straighten them. I'm just using a screwdriver, shaft, and then flexing the pins so they're all in a nice row. And then, because you need to have all 16 pins going through the holes. If any of your pins fold over, it's not going to work. If any of your pins break off, it's not going to work. There we go. So there's the chip holder. Again, small field of vision. And there's the pin sticking through. Now, when you solder these, you do not want to make what's called a solder bridge. So these are really close together, and you don't want them connected with a solder bridge. So make sure when you solder, you don't create a solder bridge. So double check your work before you give it power. So I'm going to add some flux to help with the transfer, and I'm going to push it back through, and now we're going to start. Remember, there are 16 of these, so this isn't going to be quick. So I did one on each side to hold it in place, and now I'm going to work on soldering each one. I am not doing them sequentially, and that's to help with the heat transfer again. I don't want to heat up one side of the socket faster than the other side, because I do not want to damage the pins. Technically it shouldn't matter, but that's how I was trained when I did electronics, was even though they're in a row and you're doing it with a soldering iron, try not to heat up the component, whether it's a component that has power or just a component holder. In newer electronics, they have a liquid solder bath that the circuit board runs through, and it sticks to wherever the flux was on the metal, and then they're done. So I don't have that, and so I'm doing it the old school way. Is that all 16? Yep, and I have a really close solder bridge. So right here, you can kind of see the gap. Oh, look, there's no gap. That's why you want to double check your work. The solder bridge is not there, but it's closer than I would like for my comfort. So what I'm going to do is I'm going to remove the solder. Try that again. And I'm going to resolder it. So, and now we're going to double check our work again. I am going to use a flashlight just so I can get a little bit better view. So I want to make sure I have good solder joints. So your solder joint should be domed, or not domed, sorry, domed is a cold solder joint. Kind of like a Hershey's Kiss, where it comes up to a taper and a pin sticks out the top. And I need a little bit more solder on that one because it's not all the way around it. That's why we double check our work. And that's why I said this is going to be a long video. So if you've gotten this far and you're not bored stiff, congratulations. All right. So now we have the solder soldered in the chip holder and 3 of the capacitors. So let's work on the next components. So let's work on maybe these resistors right here. Right there. So we have a black, brown, and I can't make out the other color. I think it's yellow, black, brown. So it's this one, which is a 1/4 watt, 100K ohm resistor. Right. Brown, black. Yeah, brown, black, white. Can't read that one. And then the next one is brown, black, orange. Brown, black, red. That might be red. Oh, that looks orange to me. Lots of resistors. Red, red, orange. Brown, black, orange. Brown, black, orange. So we need one of those. And the last one is red, red, red. It's a very common resistor. Red, red, orange. That's the chip. Red, red, red. And then these are fatter resistors. When I talked with Victor over at Happy Holiday Parts or Suntronics, he did say some of the stuff was changed due to how they get warm or hot from use. So he said some of the components might be slightly different. So these are 1/4 watt, 1/4 watt, 1/4 watt, but for some reason these 1/4 watts are just a heavier duty 1/4 watt. They're just bigger. Could be a different manufacturer, or it's actually a little bit stronger than a 1/4 watt, but it'll still work. You can see the resistor's larger. All right, so the one that's red, red, red is 2.2 K ohms at approximately a 1/4 watt. I actually think that's a 1/2 watt. You can see marked on here. And then this guy that's brown, black, white, which is the one closest to the holder, is 100K ohm, which apparently that is the only resistor in here that's 100K ohm, because there's only one resistor in the package. Pull that one out. Throw the package away. And then the one in between the two is brown, black, orange, which according to him is 10K ohm. What's nice is he has them labeled. It says this is for R3, which is that one. This one says R10 and 8. Right. Brown, black, red. And this one says R12, which is the top one. So it's nice that he actually has them labeled on here so you know where to put them. So the biggest thing if you do this at home, while I'm getting all the resistors out, is watch your heat. You do not want to overheat your components. So you don't want to hold your soldering iron there for long periods of time. You will destroy them. And then you're going to have a bad day. I'm going to pull off the paper. We'll fit through the holes. And that's one resistor. That was the red, red, red. Resistors are unidirectional, so it doesn't matter which direction you put them in. There is no right or wrong. That one's in. This is the excuse me, brown black, and I said it looks white. The problem is the color is so close to the, it could be yellow. Anyway, here's the replacement resistor. If you want to use your old resistors, if they still test okay on a resistor meter or ohms test, you can. I'm going to throw them all away because they're old and they've been used. So I have a trash can just to the right of me that I've been tossing everything in as I remove it. And lastly is this fella. Which is the brown, black, orange, which is that guy right there. Just bending the lead so I can flip the board over and not have them fall out, so I can solder them in. For this, I would use a soldering pen. I would not use a soldering gun because they get way hotter. A lot of them are not controllable, and the tips are much, much larger. I can put a smaller tip on this if I wanted. I wouldn't do it right now because it's 500 degrees Fahrenheit, a little toasty. But solder pens are a little bit more versatile for smaller electronics. I am really hoping this thing works when we're done. It's a crappy solder joint. There we go. It balled up. All right, 1, 2, 3, 4, 5, and 6. Let's fix that one real quick. All right, so we got 3 resistors replaced. All right, flip her back over. And let's work on these 2 Zener diodes. They're right here. They have a reddish color. There's one there, there's one there. They do have a direction, so don't put them in backwards. On the diode, especially any diode, whether it's a Zener or regular. This doesn't have any regular, so it is what it is. There's a mark on a black diode, which is a standard diode. It has a white or gray line at one end of the diode that goes around the diode because they're cylindrical. So this is for diode 1 and 2, 1 and 2. So you have your cylindrical body. Come on. Yeah, of course, everything is. So, hopefully you can see it. There's closest to my fingers over on this side is a black line that goes all the way around. So that's the direction. And on here, the black end on this one faces towards the switch, and on this one faces towards the chip. There are components that are one direction only. And as we work on those on this board, I will be pointing them out. And then when we don't work on them, we'll just continue. So there's still a little solder on that. That's why I didn't want to come out. Throw that in the bin. also a line underneath it that shows you the direction of the diode. So it says arrow with the flat line points that way. So at least this board is labeled. Now, from what I found out about the Gondola is the boards were made by multiple companies, so each board will be slightly different. So this board is different than one of the other boards I have, because I have a total of 3, including this one, that well, 2 of them I'm working on, and one of them is mine. And it's also bad, but I'm not fixing mine because I didn't get it to fix. I got it for parts so I can fix everybody else's. But the board's bad. That's why I have it. And if you're still watching this 41 minutes in, thank you. And hopefully you can learn something from it. Hopefully it helps you. It's the whole point of all these videos. I don't do this for fame or anything. I'm not going to be some millionaire from YouTube fixing little miniatures. This is just to help everybody in the community keep their stuff working, because these things get more and more expensive every year. And if you've made it this far and you're actually listening to this section and you're not just skipping around as necessary or needed, let me know how much of a video you watch. YouTube is trying to get me to change how I do these videos. They want me to show you the completed product in the first 5 seconds, showing it's fixed, and then a abridged repair, where I just show you some basic stuff, stop the video, and then show you the last component being put on or in, and then we're done. They're saying that the videos are too long and not worth the time of the folks watching them. So if you're watching this and you actually watch the majority of the video, let me know. I know a few people have said they're too long, but this is the process. I want everybody to see how I do it, because it's new to me, in the sense that when I show them, it's newer. The videos are either I've never worked on them before, or it's something custom, so on and so forth. Alright, so we got the new Zener diodes in, so let's solder back in this bridge here. That's that silver bar, because I did desolder it. It's not fully desoldered, and then we're going to remove these two at the same time. So we're going to go to these 2 resistors, which is R4 and R1, which according to this package, R4 is this one here, which it is. It's the right color code. So if you've never seen a resistor, on a resistor there's colored bands. The bands tell you what the ohm reading is, which is the resistance level, and the percentage, meaning if it's a 100 ohm resistor and it has a gold band, it means it's going to be between 100 and 101, 99 to 101 ohms of resistance. If it's silver, it's going to be 5%. I think black is 10, or brown is 10. I don't remember them all off the top of my head, but R1 and R4, so it's not that one. This one is R4, so I need the one that says R1. R1. So it's the other fat resistor. So I'm trying to get this done before Christmas. Christmas is in 20 days. I'm actually trying to get this done and back to the person before the end of this week, because they have a display viewing and they like it back in their display, which is understandable. So I don't know when the video is going to be up, so hopefully you're going to have a good Christmas, or you had a good Christmas, because again, I have no idea when I send it off to the editor to edit the video to make sure there's no issues with the sound or the video quality, background noises, since it happens, then I get it posted usually within a couple of days. R4 and R1. I'm sorry, R4 and R1. Yeah. R4 is this guy. Am I still on? Yeah, my white blocked off again. Jeez. Now, if you're OCD, you can make all the color bands face the same way. I usually do, but you know, sometimes you make a mistake and you flip one. It doesn't matter. Again, they're unidirectional. Most components, when you buy them, will tell you if they're unidirectional or not. Most capacitors aren't. Some are, like the ones we just put in. Diodes aren't. I'm sure there's resistors out there that aren't. I don't think I've ever seen them, to be truthful. Computer chips, very important. Yeah, just solder back in that jumper real quick before it falls out. Like that. And if you do this at home, take your time. Order the kit. Make sure you know what you're doing. Practice soldering if you haven't done it before. It's not terribly difficult to practice. Just get some wire and just make solder on it and maybe solder to another wire. Just do some practicing. Because if you buy the kit and you break it, meaning you cook it or something, you don't get your money back for that. So, just so you know, all these parts here to make this is just under $100. So it's not something you want to screw up. So take your time, do your best. Oh yeah, I didn't check the jumper to make sure I soldered that right. Yeah, I did. And just go from there. So let's work on these resistors here. I'm going to do the 6 transistors last. So I'm going to go around this whole piece and do R5, R8, R11, R7, and R10. R means resistor again. So I'm going to take care of all the resistors so I can get rid of these baggies of resistors, and I'll be left with just the transistors, which there's a total of 6. There's 2 in each of these bags. And then, which are off camera because I forgot it zoomed in. And then the chip, which will be the last thing I pop in. All right. So this is R7, which is right here in this bag. I wasn't trying to cut it, I was trying to pull, but apparently I didn't get the solder off all the way. So, do that, and now let's get this pin out. Right there. That one. So that was R7. R7's in this bag. So let's pop R7 out. R7. So when I took the solder off to do it, the hole still had some solder in it. So just get the bottom warm for a second and push the resistor through. Now we're going to do R11, which is this bag. says R6 and R11. I must be blind. I'm not seeing the 6. I'll double check the board in a second. Oh, come on. There we go. So, my solder is still touching. Let's heat that up a little and see if we can get it to pop up now. There we go. Awkward silence, sorry. Running out of things to bring up. Could ask how the weather is, but in real time, it'd be great. But it's going to be weeks after. And then R8, where's R8? R5, R8, there we go. Let's see, did this one desolder all the way? One side did, not the other side. There we go. Some folks that do electronics, if you watch any things online, they'll use a pair of needle nose pliers to bend the leads. I just use my fingers. Now, if they have to be a perfect bend or they're super thick, I'll use a pair of pliers. But these little resistors have really thin wires. All right, flip her over, and we're gonna solder those on. Try not to read the fumes. The fumes are toxic. If I was doing this without the camera on, I'd have a solder fan going, which is a fan that sucks the smoke through a filter to not breathe it. But I have good airflow in here, and I usually exhale when I'm soldering. That's why you'll hear me blow every once in a while, is when the smoke starts getting too close to my face. Solder I use is leaded. I don't like lead-free, or if you want to use a gas term, unleaded solder. It doesn't hold as long, it doesn't melt as easy, and it always looks dry. It doesn't look like it was a nice wet transfer. Okay, I should quit doing this. So now we need, oh, there's R6, it's hiding behind the transistor. We'll do that one next. Okay, that one has still got a good solder connection to where I can't pop it out. So we'll put a little tension with the screwdriver. And apply a little heat to get the one side to break free, like so. not coming out. Got it. All right. Apparently I missed the solder sucker joint. Two of them right smack dab in the middle of the board. Actually, looks like three of them. Yeah, there we go. All right, so that one's out. Throw it away. Flip the board back over and get R6, which is right here. So we're approaching the hour mark. I figured this would take about 90 minutes on camera. If it was off camera, it would probably take maybe an hour. Just because it's tedious. So that one's set. Let's see if R5 will pop out. Now I can do these two together. That side did. The other side is still touching something. Yeah, there's still solder on it, of course. There we go. Alright, so that was R5, and R5 is right here. Flip it over. Okay. So helping hands are almost a must for this because it makes it so much easier. All right, one more resistor, which is this fella right here. It's called R10, which is a 1K ohm resistor, which also isn't fully desoldered. Oh, not at all. So missed. Better. Now I have a hole. We're getting there. The pile of empty baggies is bigger than the pile of full baggies. All right. So, focus. All the components are replaced except for the 6 transistors. So that's the next one. Now, the transistors have different numbers on them, which is why they're in 3 separate baggies. So this one says, oh, that's the chip. This one says Q5 and Q6. So that's Q4, that's Q2, Q1, Q3, Q5, and Q6. So 5 and 6 are these 2 right here. And that's what's in this bag. Q5 and Q6. Transistors also have a specific way to be put in. Let's see if these are able to be pulled out. No. So we'll start with this guy. So one of the 3 legs is loose. I think this is the one that's holding me right now. So 2 of them were. So there, it's like a half moon shape. Most transistors are, not all. Most. You know, these are the little things that revolutionized radio, the transistor radio. So. But the majority of them are half moon shaped. There are some that are flat. There's some that have more than 3 pins. There's nothing uniform. Alright, so I've removed Q5 and Q6, which you can see has got a shape like a D, or a half moon. So on a transistor, the 3 pins are emitter, collector, and base. So each one's different. Some are NPN, some are PNPs. So you need to make sure you get the right ones. On the face in really small print is the info. It tells you what it is. And then you can look it up and determine what it's used for and what its voltages are. And which of the 3 pins is which of the 3 emitter, collector, or base. So I bent the pins out a little bit so that way I can get them close to the holes so I can work them in. And I think one of the holes is clogged. It is. There we go. When I say clogged, it's because there's a little piece of solder blocking the hole. I just had to heat up the edge to get the pins to fit through. So I bend the pins into a triangular pattern like the holes in the board. And usually I'm pretty close to getting them so they just drop right in like that. Those holes are good. So now we flip it over. Because the 3 holes are like this, when you push them in, they splay out. They'll hold themselves in most of the time. Not always, but most of the time. Same thing. When you solder 1, give it a second. You can go to a different one on a different chip. If you're doing one at a time, give it a second to cool down so you're not overheating the component. Transistors are sensitive to heat. Check my solder. Looks good. All right, next 2. This is Q1 and Q2. So Q1 and Q2 are this one and this one. So the 2 that are basically next to it. And yep, they're solid, so that means there's still some solder on them. Alright, so it's this pin here, and this pin here, and this pin here. There we go. There's one. Or that's one of the two. That's actually number 2. And then now let's get this guy out. Sometimes the helping hands get in the way. There we go. Now I just need to clean out the holes because there's a little too much solder on those. That's why I didn't want to come out. There we go. Alright, 2 more transistors for the garbage. 1, 2. And 1, 2. Yeah, Q1 and Q2. Alright. Flip it over. So. Alright, there's Q1. And there is Q2. I'm going to flip it over. And I gotta keep looking up. So sorry if it goes off screen. I'm looking down and the viewfinder is above me. So now we're gonna solder these on. I won't know till I get back from the editor how many times I went off camera, but it wasn't intentional. It's I'm focusing on the work and not on the camera. Okay, why won't you solder? There we go. Looks good. 2 more transistors and then the computer chip. Alright, so now it's the outer 2, which are over here, which is Q4 and Q3. So Q4 and Q3. So the top one and the bottom one. Opposite ends of the board. So I'll do this guy first, which is 1. And 7, and hey, look, all the baggies are there except for one now. Alright, this guy doesn't want to push in, and that's because one of the holes is clogged. So there we go. Now it pushes in. One. Got one. Got one. One. There we go. All right. So, before I go on to installing the chip, I'm going to double check every single solder joint on here and make sure I have complete connections, as we did so many. So it might be off camera while I examine it with my magnifiers real quick. So I do have a bad one. Plus I have to resolder all the jumpers. So I got to do that. And I got to put the motor wires back in. So I have one bad solder joint that I see where it didn't fully encapsulate the ring, and then all the jumpers that I desoldered. I only soldered one back in. So there's the one I fixed. This is a jumper. This is a jumper. And that's a jumper. And that's a jumper. I can't tell if I'm off camera, but I think I am. I'm just soldering the wires back on. But I'm holding them in with my finger at the same time I'm soldering. That's why I pushed the thing out of my way here. So I got one wire soldered in, and now I'm going to do the other wire. And the reason I want to get everything done now is I want to make sure there's no missing solder pads, meaning that everything has something in it that's supposed to. There's 3 holes in the board for the screws. You can see them. But I want to make sure everything else is done. I want to make sure we have good adhesion. We don't have any crappy cold joints. There we go. So everything is now done. This is a grounding strap. You know what? I'm going to zoom out now. No! Been sitting down for 1 hour and 15 minutes. Boy, my legs hurt. This. There we go. So, this is a solder strap. She's old. She's, the wire's still good. It's just the insulation's coming off. But, it's what I used to wear when I did electronics. So this thing's old. Anyway. So I'm going to use this for the chip. So you want to put on a softer piece of skin. That's how I was trained. Now this has an alligator clip. I remember right, this should pop out. Yeah, it does. And then this I can either stick into the ground of my machine, which this one doesn't have it. That one has it. I have a machine here and a machine there. Or you stick that into the bottom socket of your wall socket, which is what I'm going to do because I don't want to turn that machine on. Ugh. There we go. So that is now plugged into the bottom center hole on the wall socket. That way, if it doesn't work, I can't be accused of frying the chip. I'm electrostatically grounded. There's our stack of bags. Okay, so if you look at the chip to the left, this side, you'll see the little indentation in the chip, which matches the indentation in the picture of the board, which matches the indentation in the chip holder. And generally the pins are wider than the holder, so you kind of have to squish them in a little bit. And it just pushes in, like so. So what this does is it prevents you from soldering the pins in and causing them to overheat the little bitty components inside this little rectangle. That is the entire point of that holder. I'll go ahead and take this off because I'm now done and I don't need that now. Yeah, we're going to plug it and put it away. So, technically, it's done and it should work. Technically. I'm hoping it does. It's a very expensive kit to buy. As I said, it's just under $100 for shipping, so it's an expensive kit to buy. Do is clear off some of my bench here so I can put the gondola up here so I can actually solder the wires back onto the motor and screw it in to its place so we can test it out. So little house fits inside the big house, and if you have this piece, that's how it fits in the box. But the houses are connected by the cable. Twisted. So this is where all the rocks go. This is how you take it apart. So you have to remove all the rocks. And there we go. So it doesn't go component side up, it goes component side down. And then so that can reach the switch. It's time to charge this again. So before I took the wires off the motor to take the board out to start the video, I did mark the black wire on the motor. The motor's underneath all this, and there's 2 layers to remove. And then you have the gearbox and the pulley and the rope and the string and the, yeah. So to prevent that, I just desoldered it. I also didn't want the motor flopping around while I was working on the circuit board because the motor's heavy. So the wires go in here. They come in from this way, but you gotta solder it this way. So that's why I just rotated it 270 degrees. So first things first, gonna straighten out the wires a little bit, and we're gonna re-tin them. It stops moving around. Now I'm gonna re-tin the motor. 1. That's 2. So when I pulled this out, the black wire was on the bottom, and the green wire was on the top. Apparently I just can't see it. There we go. The solder fell off and it's dripped onto the plastic. Scrape it off real quick. There we go. Make sure we do a little tug test just to make sure, because I didn't want to go on the first time. So there we go. It is now back together. The power clips here was also not only clipped but hot glued, so if it works I'll hot glue it back together. That's why there's some hot glue on it. In. There we go. So there's the power. And now the switch, let's see. Should go this way. Click, click. Good. Okay. I don't think my bench is big enough. All right, let's grab the power supply. So this is the one it came with. It says 6 volts DC, 200 milliamps. I don't know if that's correct. I know they have it written on the side, but I'm going to use my machine. That way it tells me the exact milliamps, because I am curious if one of the reasons it died is the power supply is too weak. Meaning it doesn't put out the right amperage. It's the right voltage. Because I thought this had a higher voltage, and I could be wrong. It could be 200. They don't tell you on the boxes. Red the center. Set for 6. It's plugged in. It's drawing power, but it's not working. Six volts. What I'm doing is I'm double checking everything again. I guess it's triple or quadruple checking. Something on the piece of glue or something. Maybe some cooked flux. Oh, it's plastic from the screws. Alright. Whatever that connection is. Oh, I missed one of the jumpers. Oh, no, it's there. It's not the greatest solder joint, but there's a solder joint there. So I'm going to touch that one up. just going to touch up a solder joint. Try it again. Maybe the switch is bad. Because when I have it in one direction, it shows a 110 milliamp draw. When I flip it to the other direction, it shows a 0 amp draw. It shouldn't. It should show, and this thing should be spinning. The motor did work. I tested it before I bought the kit. Desolder one wire off the motor, and then I'm gonna put power on the motor again just to make sure my initial testing when I got this is still the same. Click. Alright, works perfectly in one direction. Let's see what works in the other direction. I have seen motors lose one direction, not the band. Nope. Alright, so the motor's good. So that didn't fail. Shouldn't have failed. It's been sitting in a box until I got the parts. The reason I desoldered one of the legs of the motor is so I don't put power backwards to the circuit board. Circuit board is supposed to get power from the power plug, not power from the motor. Okay. Now I'm going to test the switch. We're going to test the switch by checking to see its continuity in each of its two directions. So this is all stuff I did about a month ago before the kit showed up. But it's not to say something didn't change. Now that it's got power. So we have the switch all the way to the far side. Of course I can't see. Gotta take this up. There we go. And flip the other way. Switch may have failed to have continuity no matter what. I should have OL in one of the positions. I don't see any reason why this shouldn't be working. thought that was a solder bridge. It's not. I am going to touch up the switch solder though. It's got a hole in it. I didn't try and desolder it, so that's probably just from when it was made. I'm also going to touch that one up. And so the pin on the switch. There we go. So that one's probably factory. So there's 6 pins on the switch. In the middle of the top row, they had a C instead of a circle around the pin. So I just filled it in so we ensure we got good connection. Alright, let's try it again. So I put the house together so I could try it with a load of the gondolas. Now I just got to test it with me flipping the switch and no load. $11, 0. All right. I'm smelling the circuit board. See if you can smell anything, because when electronics go bad, they have a very distinctive odor. Also feeling for any hot spots. Well, I think I'm going to have to check with Happy Holiday parts on this, because I don't know if I got a bad component. If I did, it'd probably be the chip, because that tells it what to do. Nothing smells. Nothing's discolored. No smoke was coming off of it. It's usually an obvious sign of a problem. I don't smell anything. Not to say one of the components wasn't defective. A bad resistor, a bad capacitor, bad transistor will screw everything up. So I'm going to pause it here, and I'm going to contact him tomorrow, because today is Sunday and he's not there. And I'm going to see if I can get some info. And then I'll let you know what the outcome is. An hour and 41 minutes now, and not working. I don't like that. It's a lot of time to fix this, to find out that there's something wrong. Motor works, switch works, power port works. Technically, this would work fine, because right now it's only drawing 100 milliamps versus the 200 this is rated for. But there's no motor involved, and when the motor's on, it's not 100 milliamps. It was like 25. There's no load. It's not pulling the gondolas either. So once you put a load on it, of course, it increases its power consumption. So I have no solder bridges. I thought I did. I don't. I touched up the switch solder, and I resoldered another jumper. It was soldered, but I didn't like the solder. It didn't have a nice curve to it. So, yeah. That's basically how you do it. Even though it doesn't work, that's how you do it. I am not happy it didn't work, but it's something. It's a start. So, anyhow, as far as this goes, we're going to pause now, and I shall return with info, hopefully. So anyhow, give me an update here. Well, in your world, in a couple seconds. In my world, several hours. Like 13 or 14 probably. Alright, shall return. Okay, it's the next day. I spoke with Suntronics, and they're thinking that the chip is defective. It does happen every once in a while because this is a very old unit. It's pushing 30-ish, somewhere around there. So, at least in this part of the video, it shows you how to do it, carefully to where you match up the correct components. If you do them one at a time, it makes it easier, but you can do them all at the same time since he does label the bags. And, you know, take your time, be careful, don't overheat the board, be careful with the chip. He says it's not static sensitive, so technically I didn't need the strap, but it never hurts to be safe. But anyway, he's going to send me a new chip, so I can just pop this one out and pop a new one in. So we will be revisiting this piece when I get it. So it'll be about a week for me to get the part, and we'll go from there. So yeah, there's not much more I can tell you other than you can get the kit on Happy Holidays with an S, parts with an S.com. Usually I link everything below. It should be there. And then I'm not only going to revisit with this, replacing the chip, but I have another idea on how to make this work. I'm going to test it, and if it works, I'll put it in one, since I guess I have two other ones sitting here, to see if it functions like it's supposed to. And if that's the case, it'll cost you less money, less time, and less hassle to fix this yourself. So the biggest part is the mess in the bottom. All this gravel that goes right in here, which is right there. And then the tall one, which is right off camera, has about twice this much gravel in it. Maybe 3 times. I know that both bags will almost fill one of these 1 gallon Ziplocs to the top. It's a lot of white rock. So anyway, move that back. So we're going to stop right here, and we'll revisit this in the future, probably in a month. I'm thinking when the video will come up. I don't know. And I send it off to editor. It's whenever it gets edited. So it just depends on all our schedules. So in the meantime, I'm just going to set the board back down and pop the screws back in so I don't lose them. And I'm going to set this off to the side until that microprocessor shows up and I can go ahead and swap it out and test it again. The only other thing that we could think of when we were talking about it was maybe one of the transistors is defective. So, but I have transistors, and what I'll probably do when I get the chip, or in the near future, I'll probably take the transistors off the board and test them. I have a transistor tester that tells me if the transistors are good or bad, but you can't do it on the board. So I will take them off and test them. But I'm going to put this one to the side for the moment because it is the holiday season and I have a buttload more to work on. And there's not much I can do with this one, at least for a couple of days. So we'll return to this one in the near future. So I appreciate you watching if you did. Sorry for the anticlimactic result. It does happen. Sometimes things are not repairable, and sometimes things are repairable, but they take multiple attempts. So, and then sometimes things have to be modified. And I'm probably going to do that. Like I said, I have 2 more of these So I'm going to see if I can one of them is mine. I'm going to see if I can modify, I'll probably do mine, and make it work to where it's a much easier repair. Looking at the circuitry, it's way overcomplicated for what it is. But this was 1992, I think, is what it said on this one. So we've gotten smarter. Well, we hope we did in the last 30 plus years. So, alrighty. Thanks for watching this really, really long one that didn't turn out the way it was supposed to for now. And we shall return. So until the next one, have a good one.